Right, day 17. Pyroclastic Flow. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling and almost continuously now, but the strange valves brought you some time. It's definitely getting warmer in here though. The tunnels eventually open up into a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shapes, where a pound is a rock and a period is an empty space. This is going to be Tetris. Alright, so boom, 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 boom. Great. The rocks fall in the order shown above. First the straight one, then the plus, and then so on. Once the end of the list is reached, the same order repeats. The minus or the slash falls first, then 6th, 11th, 16th. Okay. They do not spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect the jets of hot gas will have on the rocks as they fall. Your puzzle input. For example, suppose this was a jet pattern in your cave. In jet patterns, left means a push to the left, while right means a push to the right. The pattern above means that the jets will push a falling rock right, then right, then right, then left, then right, and so on. If the end of the list is reached, it repeats. The tall vertical chamber is exactly 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units away from above the highest rock in the room, or the floor if there isn't one. After a rock appears, it alternates by being pushed by a jet of hot gas 1 unit in the direction indicated by the next symbol in the jet, and then falling down 1 unit. If any movement would cause any part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused a falling rock to move into the floor or onto an already fallen rock, the falling rock stops where it is, having landed on something, and a new rock immediately begins falling. To prove to the elephants your simulation is accurate, they want to know how tall the tower will get after 2022 rocks have stopped, but before the 2023 rock begins falling. In this example, the tower of rocks will be 3,068 units tall. How many units tall will the Tower of Rocks be after 2022 rocks have stopped falling? Okay. Alright, so this one is a little bit more straightforward, although there's still a fair number of edge cases. The second part is going to be a little bit rougher, but we'll walk through it. Okay, so the first thing we need is we need a list of our rocks. And basically, I just put them in as coordinates where the top left of the sprite is always going to be at 0, 0. Even if there's nothing there. And so like this one will be 0, 0, 0, 1, 0, 2, 0, 3. That's going to make our straight line. And then the second one will be 0, 1. So skip the first block, go to the second block, and then 1, 0. So here, and then 1, 1, 1, 2, and then 2, 1. So it makes a little plus, and so on. Basically, add them in, no problem. I just need some way to mark them. Then our jets is just going to be just the string of the input actually, because we're just going to iterate through them as a character array. No problem there either. And then we have to build up our chamber. So our chamber is going to be a mutable list of arrays and then booleans, and basically booleans is blocked or not blocked. And so to start it off, we're going to add a floor. So we're going to add 7 across, and those are all set to true, so there's something there, and then 3 lines for false. And then basically we're going to keep track of the moves, and we're going to keep track of the rocks, and then for every rock that we add, we figure out which rock we have by modding it versus rock size, because that way we'll just circle through the list over and over. And then our height is easy enough to find. We basically take the last row that has any trues, and then we add the height of our rock, basically like, you know, so like these two are both going to just be 1s, and then, or actually that's down to 2, this one's a 4. So basically, however high our rock is, we're going to add that in, and then we're going to place the sprite basically 2 from the side, and then with the bottom being 3 up. So we need to add to that. If the chamber is not big enough to hold the new rock, make it bigger. It doesn't really matter if there's extra because we're only checking for ones that have trues. And then we're going to set the rock to falling. And then basically from there, we just check everything. So we find out if we're going left or right. Again, same thing, modulo based off of the length of the jets. So again, once you get to the end of the jet list, you're going to start over again. And if it's left, we check to see if it hits the left wall, and then we check to see if we can move it left because of trues or not. And then if everything is good, we move it left. If it's not left, then we do the exact same thing, but we check to the right wall, and we check to see if it's going to run anything if it moves to the right. And then as far as like checking to see if it hits anything, that's easy enough. Basically, we just look at every point in the rock. We move that point one space to the left or the right, and we check it. We could probably be smarter about that because like if you think about like the plus, there's no way the center of the plus ever could hit anything. In fact, I could probably just take it out and it would work exactly the same. But whatever. This part's all fast enough. And then once we're done with all that, then we go through and drop the rock, which is basically the exact same thing, except instead of checking the points to the left or the right, we check the points with our height down one step. And if it drops, then we decrement our height, we continue to say it's falling, and we repeat the whole loop over again. Once it no longer drops, then we don't update the falling, and it comes out of the loop. And so then after falling, we have to actually set the true inside of our chamber, otherwise the next rock won't know where to hit. And then the only thing we have to do at that point is just return. So we're just going to take, again, the index of the last row that has any true value. And that runs through pretty quick. The second part is instead of doing it for 2022 times, we're going to do it for 1,000, million, billion, 1 trillion times. I assumed that it was going to be a larger number for the second part through, and so I was thinking about ways to kind of clean that up, basically like trimming off rows that we know we no longer can use, things like that. But the problem is with the trillion, just having a for loop that does nothing a trillion times takes a while. So it's kind of untenable. So we have to be smarter about the way we come across that. The way I thought about it was to find it had to be some sort of cycle. I checked to see if the cycle would end on the beginning of the input and rocks. So like if you ever start the whole thing over again, if it does, it doesn't do it for a long time because it was, I did to 100 million and nothing. So then I had to be a little bit smarter about it and try to find out where the period is. I basically just put that into a hash table, and if I had a hit, threw it out, and then I just did the math manually. The reason this video is out a little bit later is because I went back and cleaned that up for the code, which we'll get into in a second. So basically, we know that the max period has to be the length of the jet list times the rock size. So if there's 5 rocks and 1,000 jets, then we know that somewhere in that 5,000, we have to get to the point where we hit a repeat. Otherwise, we would just basically get to the end of it and we would start all over again. So it's somewhere in there, there has to be a point where it starts repeating. And unfortunately, the input is still quite large, so you have to be kind of smart about it. The jets, for mine at least, are 10,092 characters. So that means the max period's up to 50,000. And so the way I'm doing this is I'm storing an array of twice the max period, and until twice the max period, I'm going to just drop rocks and do everything exactly as I normally would. And at the end of it, I'm going to just add that to the table. Then go through and find the period, and to do that, basically, and there's probably a smarter way to do this, but I just go through everything from 1 until max period, and then I check to see if the offsets. So like if basically if I was going to start where I am and then I offset by that max period, if the difference is always the same for every one of those, then we're good. If the difference is not the same for every one of those, like if I jump 10 spaces ahead and then I jump 1 and 11 spaces ahead and I jump 2 and 12 spaces ahead, if those differences are not the same, then that's obviously not the period at that point. So once I have that, then I just have to find out the offsets, so how many things we do after the last period, and the number of periods, which is just how many periods we can stick into the trillion, and then just a little bit of quick math and pops out the correct answer. So it runs pretty quick still, so no complaints. Latest code, of course, is always in the GitHub, so check that if you want to run through any of this, or hit me up in the comments if you have any questions. So thanks, and I'll see you tomorrow.